In this video, we will learn about magnet and magnetism. You must have seen or played with magnets. So what is a magnet? A magnet is that object which attracts pieces of iron, steel and other magnetic substances, for example, nickel and cobalt. The property of a magnet by virtue of which it attracts iron pieces and other magnetic substances is called magnetism. So magnets are classified into two categories. The first category is of the natural magnets, magnets which are found in the nature. And the second category is of artificial magnets. So what are natural magnets? Natural magnets are pieces of lodestones found in nature. These exhibit weak magnetism and are of irregular shapes and sizes. Therefore, these are not commonly used as magnets. The second category is of the artificial magnets. These are magnetized pieces of iron or steel or other magnetic materials. Artificial magnets can be prepared in different convenient shapes and sizes, and hence these are quite strong. Some common forms of artificial magnets are bar magnet, horseshoe magnet, ring-shaped magnet, cylindrical magnet, and magnetic needle. However, most commonly used of magnet is bar magnet. Now, in this slide, we can see the images of natural magnets on the left hand side, whereas on the right hand side, we can see the images of different types of artificial magnets. Let us now discuss the properties of a magnet. The first property which we will be going to discuss is the attractive property. This property states that a magnet attracts pieces of iron and other magnetic materials towards itself. This is a very simple property. Moving on to the next property, which is directive property. This property says that if magnet is suspended by a fine silk thread like this, I'm taking a bar magnet, so the magnet will automatically align itself in the north-south direction. Suppose this is south direction and this is north direction. So when in equilibrium, this axis is called the magnetic meridian and it is specific to that place only. Magnetic meridian. And this is the same thing which is written here. The direction in which a freely suspended bar magnet rests in equilibrium position is known as magnetic meridian at that place. Now moving on to the third property. Each magnet has two magnetic poles where its magnetic attractive property is maximum. If a bar magnet is brought near a layer of iron fillings, maximum quantity of iron fillings clings to the magnets near its two ends. These points are called magnetic poles of the given magnet. The pole which points towards north direction of the earth is called north pole, and the pole which points toward the south direction is called the south pole of the magnet. Fourth property is two magnetic poles of a magnet cannot be separated by any means. If a magnet is divided into two or more pieces, each part behaves as a complete magnet and has both north as well as south poles. This clearly shows that magnetic poles exist only in pairs and a single monopole cannot exist in nature. So if I have a magnet, if I have a bar magnet, there is north pole and there is the south pole. If I break it into two pieces like this, both the two pieces behave as a complete magnet. Each magnet has its north pole as well as south pole. The second piece will also have its north pole as well as the south pole. And therefore, a single monopole cannot exist in nature. Moving on to the next property. Like magnetic poles, that is north and north or south and south, repel each other, but unlike poles, attract each other. This is fairly simple property. Moving on to the next property. Each magnet has a region around it in which the force of that magnet can be detected. Such a region is known as magnetic field of that magnet. Magnetic compass. You must have seen or at least heard about magnetic compass somewhere. So what is a magnetic compass? A magnetic compass consists of a small aluminum box and a small magnetic needle which is pivoted at the center of the box. You can see in this diagram, There is the center, and there is a needle which is pivoted at the center. This needle is free to rotate in a horizontal plane on the pivot. Top of the box consists of a glass cover so that the direction of magnetic compass needle may be easily observed. The compass needle gets deflected when brought near a bar magnet on account of the force experienced by it due to the magnetic field of the given bar magnet. So when a compass is brought near a bar magnet, the compass needle gets deflected. The compass is majorly used in helping us with the directions, that is north, south, east, west, etc. I hope this topic is clear to you. Thank you.